Hello, my name is Paul Walsh. I work as the General Manager for CIM, and CIM has developed innovative software that helps people operate large, complex assets at their peak performance. And my objective in this case study demo is to give you an overview of how a good data analytics solution can complement or enhance or augment any companies that want to start on an ISO 50001 journey. So the agenda today is just to talk about ISO 50001, touch on some of the high points and outline what you need to start on that journey. Then touch a bit on what the implementation involves, and then maybe give you an overview of CIM and how we help clients get going on that journey. And then talk about a case study. So show you some dashboards of anonymized sites that we have helped in Irish manufacturing to improve their 50001 program or to get started on a brand new certification. So ISO 50001, it is the international standard for energy management. It does align best practices right across the globe and tries to work year on year on incrementally improving those on any of the sites that get certified. And it is applicable for any size organization or any type of organization. And what you need to do, right? Firstly, you definitely need to have an energy policy, which can be quite easily drafted up. You need to establish some baseline energy targets and the objectives of the plan you want to include. And then you need to really use the data. And a lot of the auditors want to see how the data is collected and how you're using that data to identify opportunities for improvement. And then you really need to show to them that you have a monitoring verification. So you're looking at before versus after and ensuring that the savings don't degrade over time. And how data analytics dovetails with 50001, in our opinion, is that any data analytics platform, by virtue of the fact that it needs data, it needs quality data, a part of what a data analytics solution provider like CIM would do is we would collate and cleanse the data and ensure that it's being logged in 15-minute intervals. We would do some metering gap analysis for clients. And once the data hygiene has been sorted, we ingest that data into a platform, and then we run fault detection diagnostics on that data set. But a huge body of work in preparing the data is getting it in a central repository. And that is typically a big body of work for anyone who's starting on the ISO 50001 journey. So what we have found is the fact that we have got data out of the individual silos that resides in a building and brought it to one central place is a huge value add to anyone starting the 50001 journey. So that's where data analytics and 50001 certainly complement each other at the very start. And then we use the data to help identify opportunities for improvement. So this is part of the fault detection diagnostics. It detects where plant and equipment is not running efficiently. So often the low cost and the no cost opportunities fall out of the data, and they can be implemented quite effectively and quite quickly. You get an element of operational control because you can put in upper and lower control limits on the data set. So when equipment begins to deviate, you can immediately act. And then it builds that M&V, or the monitoring and verification, which is critically important to ensure your savings don't degrade over time. And how the 50001 process works, it works typically on this Deming cycle where you have this plan, do, check, act philosophy. And a big part of what data analytics does is around this planning bit. So in order for companies to understand what they need to do or where they need to deploy resources, on whether it's people or money, they really need to understand where the biggest bang for the buck is. And data analytics will do that. It won't, typically sites can depend on vendors or equipment manufacturers to say, listen, that chiller is X number of years old, it needs to be replaced. Data analytics can often contradict that, and it'll say, listen, that piece of equipment is running fine. If you do want to upgrade, here's a better opportunity from an energy reduction perspective and from a return on investment perspective. So the planning part of the ISO 50001 process is very much where data analytics overlays with it and enables the site to execute the biggest value projects. And again, from the auditor's perspective, they love seeing how data is informing the decisions that are being made and continuously doing so. On the performance side, the energy performance indicators, they're called ENPIs. Once the data is ingested and normalized, we can put ENPIs in place that will track equipment performance, and that typically blends data from multiple sources, so from your building management system and from your energy management system, to get ENPIs like coefficient performance on a chiller, because you typically need flow meter data from your BMS, and you might need energy meter data from your energy management system if you have that on site. Again, the monitoring refers to how the savings are maintained over time. And then improvement is that year-on-year performance improvement, that you say, okay, we've done these amount of opportunities for improvement that the data recommended. Here's the additional body of work that we want to do, and then you tighten your ENPIs to make sure that doesn't deviate over time. And some of the outcomes that clients get from our Peak platform, and you can see on the left-hand side of this slide here is the ISO50001 type ones, which is energy and OPEX reductions, the better environmental rating. So that refers to buildings that have certifications such as LEED or GRESB or WELL, those type of building energy ratings standards. We move to data-driven maintenance, so we move away from the scheduled maintenance programs to the condition-based maintenance. And then this site gets carbon reductions. A lot of the large corporate clients we work with have CO2 reduction targets, and they want to achieve them. And by virtue of the fact that implementing ISO 50001 gives them almost an immediate demand side reduction, you get an associated CO2 reduction as well. And on the ancillary benefits to the site, right, you get an element of technical engineering support, like a virtual engineering team that you didn't have in place before. You also get improved comfort or thermal conditions for your employees. That's, I suppose, anyone that has validated spaces, you're ensuring that it's not too hot or too cold in there for them, or in an office environment. You also get increased equipment lifespan, because equipment is not running outside of its design parameters anymore. The data is driving those type of decisions not to stop that type of conditions occurring. And then you obviously get increased uptime, because the plant and equipment is not falling over or not failing as frequently, because the data is driving the predictive maintenance on it. So what I'll do there is I will pause and I will show you what the software looks like. So this is CIM's Peak platform, and our landing page shows the energy consumption, and we baseline consumption, which is extremely important from an ISO 50001 perspective. It shows before, which are the gray columns, and after, which are the blue columns, and you can see a year-on-year reduction. For ISO 50001 certification, we need to get the energy data and break it into what's called significant energy users, and visualize those in donut charts or in cumulative stacked column charts, and track the performance of chillers and other significant compressors, significant energy users on site, and report out and when the consumption has gone above or below certain thresholds. Other dashboards that we've built from an energy visualization perspective is around energy awareness and transforming the energy from a kilowatt hour or gigawatt hour value into values that people might readily understand. So the number of smartphones charged, or the number of trees planted, or the number of barrels of oil equivalent. And it just allows people on site to get their head around the energy reduction, and also improves the energy literacy on site. The other aspect of this dashboard is, again, from a 50001 perspective, is it looks at the equipment run hours, and it shows the difference in the last week's average run hours compared to the 3 months before that. And you can see examples of when plant and equipment has changed, and that anomaly is flagged to the CIM engineering team, and we work collaboratively with the site to resolve those issues. So this element of control and monitoring verification of savings is a key part of the ISO 50001 standard, and it's baked into part of what the Peak platform gives our clients, and the resolution of the tickets is a closeout. So from an auditing perspective, there's a full circle of closures of the actions there. So thank you for your time today. I promised I'd keep it short and sweet, so hopefully I've lived up to that. If you have any questions, please reach out to me directly, paul.walsh@cim.io, or we can continue the conversation by visiting cim.io and find out more about what our building analytics platform does and how we've helped some tier 1 clients.